Welcome back to A-Level Further Mathematics, Mechanics 1. Today we're doing Finding Resultant Force. This is one of the most basic skills that you need to use in Mechanics 1, and I hope you enjoy it, and let's start. So, forces don't often exist by itself. Most of the situations, there are multiple forces acting on a single object. Let's say when you're sitting on a chair, you are in force of the gravitational force forcing you downwards, while the chair supports you upwards. And these are the basic fundamentals of mechanics. And yeah, that is going to be demonstrated with force diagrams that we've done not long ago. And so prepare to use your calculator because we're going to use them for good purpose. So let's start. So here is two forces acting on a red particle, and we know that there is 4 newtons going to the right and 3 newtons going up. So what can we say about this? Well, we have to know that forces are factors, so they actually can be added up. And the way they add up is when you put the back of the arrow to the start of to the top of another, and create a similar or identical arrow of same length and magnitude, and you can draw another arrow which is also 3 newtons, and basically you're just shifting this along this line so that the back is linked to the front. So this means, in another way, the particle didn't go up and horizontal the same time. It goes horizontal 4 newton, it stops, and go up 3 newtons. That is exactly the same as both force exerting at the same time. So that wouldn't make a difference to the result. And note that these two lines are parallel, so this is 90 degrees as well. Okay, so that's the first step. What next? Well, we know that because after the 2 arrows steps, which goes horizontal then upwards, ends right here. So we know that the resultant force is from the start of the particle till the end of the arrow. So that is the resultant force, and put an arrow here to show the direction, and it ends right here. So now we've got a triangle. What do we know about triangles? Well, Pythagoras says the square of 2 sides of a right angle will result in the square of the hypotenuse side, and that is exactly what Pythagoras theorem is. And trust me, because arrows are factors, they follow trigonometry rules, so we are actually going to use trigonometry to solve a lot of mechanics questions. And note that this triangle consists of 3 and 4, and we know that this is a Pythagorean triangle that have a whole number hypotenuse, which is 5 newtons. Sorry guys, I'm not sure if you can hear that, but people next door are making serious noises, and yeah, I have no control of that. So if you do hear yelling and shouting and swearing and things, just leave it alone. And so now back to the question. Now we know that this resultant force has a magnitude or size of 5 newtons. What about its angle? Well, again, we can use trigonometry to solve that. And we know that there are two given sides. 3 Newton is opposite, and 4 Newton is the adjacent side of this particular angle, and we're going to find this angle, and so find the bearing of this. You can do either this angle or this angle, it doesn't matter, as long as you can find this angle, which is the bearing. What we do is, to find this particular angle, we always use the value that is given, so that you don't make follow-up mistakes. So if this is not 5 Newton, you don't mess up this answer. So what you do is, we have for sure a correct opposite and a correct adjacent. So according to sine, cosine, tangent, we will use tangent rule, which is in fact 3/4, because it's opposite over adjacent, which will give you a rough 36.9 degree. So that is the angle right about here, and to find this angle, or the bearing, is just 90 degree minus 36.9, so that would be 53.1. so that will be the bearing of this resultant force. So we know the bearing of this force is 53.1, and the magnitude is 5 newtons. So we have found the resultant force using trigonometry. So now I have another question here. So we have a force going upwards and a force with a suppression? No, a downward 45 angle force, which is 4 newtons. So how should we solve this? Well, we know that we must go one arrow then the other arrow. So either I can go the 4 Newton route, then go 2 newtons up, or go 2 newtons up and 4 newtons down. And for this particular question, I have managed to I will use the go up then down method to find the resultant force. And so always start one arrow from the red dots and follow one arrow, then put the other arrow on top of that as the start. So right now I know that this is 45 degree, and I know that if this is straight line extended, which is like this, then this angle will be 45 degree as well. So that would help me either because it's this line is straight, we can just shift the whole arrow upwards and including these angles. So I have created another diagram that looks like this, and it's just basically this part shifted upwards, and the angle is still the same, as you may see. And so this is the diagram we're planning to use to work with. So now comes a problem. There isn't a right angle right here, because if we connect these because when we connect these 2 points, the resultant force is not horizontal. So what can we do to find the resultant force? Other than just classic right angle trigonometry, you might have came across a rule for triangles called the cosine rule, and this is the equation for it, is the unknown side squared will be equal to 2 sides squared minus 2ab, which is 2 and 4, cos the angle in between, so it's 45. And that sounds a bit terrible, but I will represent that with this equation. So the resultant force squared is equal to the upward force squared plus the downward force squared minus 2 times upward times downward cosine 45 degree. Whew, that's a lot. And so you should be able to find that r squared is 8.68629, and rounded off, r will be 2.95 newtons. So this is one of the answers that we wanted to give. And what next? Well, we need the angle, so let's find the bearing, should we? So we know that the upward force is always upwards, so if we want the bearing of it, we need to find this particular angle, and this angle is obviously larger than 90 degree. So again, we can use the cosine rule, and that is another version of the cosine rule that lets you find angles, which is cosine c equals a squared plus b squared minus c squared over 2ab. And because we've found r, which I shall label right now r, we can use the value r squared and r for this particular equation, so that it would be cosine right angle equal 2 squared plus r squared, because it's adjacent to each other. It's a and b is always next to angle c, and so it's 2 squared plus r squared minus 4 squared over 2 times r. So that would result in this particular equation. And if you do the arc cosine function, you should get that angle C equals 106 degree, roughly. It's 3 significant figures again, so this angle will be 106 degree. And now we've got the angle and the resultant force, we have solved this particular question. So what we need to do is just to label that arrow on this particular this starting diagram, because we made another one. So we shall use a red line to demonstrate that the resultant force is 106 degree downwards. So it's 16 degree down from this horizontal line. So I guess it's about here. And its force is 2.95, so it's actually shorter than 4 Newton. So I'll predict it's right about here. That would be a fair guess, I think. And here, this will be the resultant force. And just remember that you need to label the original diagram with the resultant force and its angle, actually. So I will write down right about here. I will say this is 106 degree, so that would be 2.95 newtons. Remember the units are crucial, and so that would be a correctly labeled diagram. So that's pretty much all about resultant force. It's just about how you interpret the arrows. And yeah, so let's do some example questions. So here are two questions for you to find the resultant force. One of them is just a V-shaped classic arrow, and one of them is a right-angled triangle. So this will be actually easier than question 1. But if you know how to do it, I'm just gonna leave it to you and pause the video, finish these questions, and I will give you the answer. If you don't know how to do them, go back and check the same go back and watch the video again, and so you understand it better, or even ask your teachers for more details. So in 5, 4, 3, 2, 1. So correctly labeled diagram will look like this, and it doesn't matter which angle you took as long as they are compatible, because I've gave you these angles. So if you used this angle as the reference, then the answer should be 50 minus 18.4, and if you use this one, it should be 90 minus 30.3. So yeah, as long as the magnitude is right, and you will probably get the angles right. So that is quite straightforward, and that will wrap up this video. So I hope you enjoyed it, and if you learned something, please leave me a like and comment below for any questions and things that I can clarify on, and I hope I'll see you in the next video. So see you next time.